All right, so today we're going to talk about how to use the unit circle and kind of fill in the rest of it. So what we learned last time of the unit circle was really just quadrant 1, just this top right area. So remember, the unit circle is like centered at 0, 0 and has a radius of 1 unit when you get all the way out to the edge. So we talked about where some of these values come from, our special right triangles. And these are their angle measurements. Remember, from the positive x-axis, 30 degrees, 45, 60, 90, etc., right? We measure these counterclockwise. But note that these values appear everywhere else. Like, if you actually just used symmetry, you kind of used the y-axis here. Imagine folding this on half, right, over the y-axis. These points end up going on top of these points. These go on top of here, and these go on top of here. And if you're noticing by looking at these coordinates, in fact, even the ones we have circled here, the values are basically the same. Just say in this quadrant, cosine, the x-coordinate, is negative because we are to the left of 0, 0, right? So worth noting there that a lot of these values are basically the same. And in fact, if you use symmetry, you can rotate these, or sorry, you go over the x-axis, you can reflect those values down, but notice that all of the y values are negative because we're below 0. So same idea over here, both x and y, cosine and sine, are negative. And don't forget, right, the cosine value of each angle is the x-coordinate, and the sine value of each angle is its y-coordinate. Okay, so kind of a legend there. Now, the other one we haven't talked about yet is tangent, the tangent function. Okay, tangent itself, tangent of an angle, is defined as the ratio of the sine of that angle divided by the cosine. It's essentially the y-coordinate divided by the x-coordinate. So we'll talk about some of these values. Say tangent here, tangent of 0, if we did the y-coordinate over the x-coordinate, we get 0. Tangent of 0 is 0. If you did, say, 90 degrees, we get an odd case here. 90 degrees, or pi over 2, the y-coordinate over the x-coordinate. We get division by 0, which is undefined. Tangent is undefined. In fact, actually in both places on the y-axis, tangent is undefined down here as well. For the same reason, -1 over 0 would be undefined. So we can kind of go in and do all of the division. A lot of these with radicals get a little bit uglier. I'll maybe do one really fast so you see. So here, if we did 1/2 divided by root 3 over 2, well, that's the same as multiplying by its reciprocal. We could then cross-cancel those 2's out, but we're not supposed to leave a square root in the denominator, so we rationalize it, and we get root 3 over 3. That is the exact value of tangent of 30 degrees. Okay, tangent of 45 degrees is actually pretty easy. Anything divided by itself is going to equal 1. Tangent of 45 degrees is exactly 1. And if you do similar what we did with 30 degrees, 60 degrees, we end up with just root 3. It's not divided by 3 there. So here are the tangent values in kind of the first quadrant, and we could copy them to the rest of the unit circle as well. Okay, now rather than just writing all these million things down, there's a nice organized way of doing this, which people have come up with. This is a unit circle table, essentially, rather than the actual circle itself, where you can read out a lot of these values. So it's got the radian measures of each angle in the very left column. Okay, from 0 all the way up to basically back to 2 pi. This would be the next thing afterwards here. Would be 2 pi. You just kind of start over again if you go past 2 pi. Degrees, this would be between 0 and 360. I don't know why they forgot the 360 here. And then all of the angles in degrees. And then here are the sine value of those angles, the cosine value of those angles, the tangent. And then remember, cosecant, secant, and cotangent, these are reciprocals. It's like this is 1 divided by sine is cosecant. 1 divided by cosine is secant, and 1 divided by tangent is cotangent. So for the most part, we won't use these three a lot. It's worth, I guess, printing out a picture of this for future use. But for the most part, we're probably going to use just these first three: sine, cosine, and tangent. So let's use this. We could use the circle, or we could use this table to answer the questions. I find the tables a little more organized. So let's do this. What if I wanted to know the tangent of 300 degrees, the exact value? Well, we're talking about degrees, so we go degrees, go down to 300, and then we want to find the tangent column. So kind of where those two intersect. The tangent of 300 degrees is negative square root of 3. And that's it. There's our answer. What if we wanted to find the sine of 225 degrees? So again, we're in degrees, so we'll go down the degree column till we get to 225, and sine is this column. It's kind of where those two would meet. Sine of 225 is negative root 2 over 2. Negative square root of 2 over 2. If we wanted to find, say, cosine of pi halves radians, now we're talking radians, so we'd find pi halves, which is equal to 90 degrees. There's kind of a nice conversion chart from radians to degrees as well. And cosine of pi halves is 0. So our answer is 0. The x-coordinate at 90 degrees. Remember, that's what cosine really stands for. If you go back and look at that unit circle, 90 degrees, cosine, the x-coordinate was 0. Okay, sine of 3 pi halves. 3 pi halves is down here in radians, and sine is the first column of our three trig functions. The sine of 3 pi halves is negative 1. Okay, what about if they give you a figure? We'll see some of these in the homework. This is really just saying cosine of the angle, and then it's giving me the angle in the figure. So essentially, they've just asked me to find cosine of 60 degrees. So we just go to 60 degrees. Cosine is the second column over here with our three trig functions. Cosine of 60 degrees is 1/2. Okay, what if they asked you for, say, sine of this angle? Sine of 2 pi thirds. So here's 2 pi thirds. Sine of 2 pi thirds is root 3 over 2. Square root of 3 over 2. Now, if they do throw in an oddball like, say, the secant of 45, you could remember that secant is the reciprocal of cosine. Find the cosine of 45 and flip it upside down and then do some math to correct it. Or, of course, you can go back to our table. The secant, this is the full table, of 45 degrees ends up simplifying as square root of 2. Okay, so for this, you're really just going to be kind of being able to read these values and have a unit chart handy. But it is important to understand where tangent came from. Tangent being defined as sine over cosine, and that cosine is the x-coordinate on the unit circle, and sine is the y-coordinate on the unit circle, and that tangent is just the sine divided by cosine. So those parts are important. As far as filling this all in by hand, I don't know, that's kind of a lot, so we'll probably just use a table now. I know some of you probably won't want to write this down by hand, so maybe, hopefully you have access to a printer. If you don't, then maybe it is worth writing down because it's a really quick way of getting a lot of your answers. Okay, that's it for today. We'll go over a lot more examples in class, and we'll show you we'll go over that left-hand trick a little bit more, show you how you can come up with at least the ones through 90 degrees without having the chart.